Hello, my name is Lindsay. We're going to go over a mathematical proof, and we're going to use proof by induction. And one way we're going to use this is we're going to use Fibonacci numbers. If you didn't know what a Fibonacci number, it's adding two previous numbers together to get the new one. So we'll go over the first 5 in the Fibonacci number sequence, just so you understand. So the first Fibonacci number is just 1. Alright? Since there's no 2 previous, we'll just give you F1, F2. Now Fibonacci number 3, you would just add 1 and 1 to get 2. To get 4, you would add 1 and 2 to get 3. And then to get 5, you would add 2 and 3 to get 5. And we can go on. We'll just do one more just to make sure the point is made. Is 6, and you would add 3 and 5 to get 8. And this series is infinite and will go on forever. But today, what we're going to show is that you don't need to know 2 previous ones. You can find the straight Fibonacci number. Fibonacci number of any would equal that 1 over the square root of 5 times 1 plus square root of 5 over 2 to the nth power minus 1 minus the square root of 5 over 2, that to the nth power, will equal any of the Fibonacci numbers. Now the way we're going to prove this works is using mathematical induction. So the first thing we're going to have to do with mathematical inductions is we need our base case. So we're going to solve this for Fibonacci number of 1. Well, Fibonacci number 1 we know is going to equal 1. So let's see if we can solve this side for n equals 1. So we'll have 1 plus the square root of 5 over 2 to the first power minus 1 minus the square root of 5 over 2 to the first power, all by 1 over square root 5. Alright, so since they're all to the first power right here, these ones don't need to be here anymore. And since they are the same denominators, we can just put them underneath each other. So that would be 1 plus square root 5 minus 1 minus square root 5 over 2. And I'm going to just take the square root of 5, and since it's multiplied through, and just put it on the bottom here. Alright, we distribute the negative, and we will get 1 plus square root 5 minus 1 plus square root 5 all over 2 square root 5. And as you can see, our 2 1s cancel out, and that just leaves us with these 2. And since they're both the same term, we can make that 2 square root of 5, which we know will equal 1. So now that we have our base case, now we can start our proof by induction. And the way you're going to do that is first we need to assume that we have the right formula. So we're going to assume that works. So we'll assume that f of k, and all I'm going to do is replace my n's with k's. All this does is just make sure that we know that we're doing a proof and it's different than a real assumption. All right. Oop. Case. All right. Our next idea now is we're going to have to prove So now that we have our assumption done, we're going to prove the plus one. Now, proving the plus one, most of the times we try to take this complicated side and work with that. But this time, it's actually a lot easier to work with this side. So, what we're going and make it equal to this. So first what we'll do is we're going to break up this. And by definition of Fibonacci numbers, remember it's the two previous numbers added together. So from k, that would equal to k plus 1, it'd be f of k minus 1 plus f of k equal f of k plus 1. Now, because we already assume this to be true, but we don't know if this is true. So we're just going to assume it. Normally we would write this out, but just to save time, we know that it'll look the same. So all we're going to do is plug this f of k minus 1 into here, and f of k into our assumption. So we will have 1 square root 5, 1 plus. Okay. Now looking at this, looks a little complicated. We're going to try to simplify it out. First we can see this square root of 5 can be taken out, so we'll start off with that. And I know we're going to have to get to this to here. So what I might want to do is put these two terms next to each other. Now the next part, we just need to be careful with these minuses. So I'm just going to keep the minus completely out of these two. And just add these two terms together. And you can see you can distribute out the negative, it would equal the same. Remember, what we're trying to do is we're trying to get it up to here, right? So, I look at these two terms, and I know they're going to have to relate to this one. So what do these two terms have in common? Well, they both have k. So we can take this term to the k power out. So if we take k out of here, well, they don't have k in common, they have k minus 1 in common. That's k minus 1. So if we take k minus 1 out, what we're left with is we're left with 1 for this term, and the difference between k minus 1 is that to the 1 power. And the same thing will be happening on this side. Okay. Now to get to k plus 1 from k minus 1, we need this term to be 1 plus squared. That squared, add to k plus minus 1, will get us to k plus 1. So the real question is this equal to well, let's see. So first, if we take this square, we can square both the numerator and the denominator. If we square that off, we'll get ourselves well, that's the case. Looking over here, that means this denominator is going to have to be to the 4th power, or to the 4th. So we'll just put that to the 4th then. 1 is just 4 over 4. And then to get this to the 4th denominator, you just multiply by 2 to the top and bottom. Then now they have the same denominator. So now we know I can put these together. Just add the 4 to the top. Okay. So all I have to do is take 1 from this 2 and put it over there. So that 4. Let's make that a 5. And now we know that that's equal. So we know this term right here, really what it is because that is 1 plus square root 5 over 2 squared. Now if we add that k plus 1 times the squared, we're going to get okay. So now if we look, we have the positive one both equal. So now we just have to go with this negative. Now since it's almost the same process, right? We just need to see if this term right here is equal to the square. So we know we're going to look for 1 minus square root 5 over 2 squared is really equal to and we, like I said, you can square the numerator and denominator. You get 1 and it's almost the same process again. We'll just make sure we'll get to this, to the fourth equal to 4s. Multiply 2 by the numerator and denominator. Okay. Once again, both the numerator and the denominator are equal. So we'll just extend our line out here. And once again, all I have to do is take the 1 from the 2 and put it in the 4. And see that, really, this term right here is this squared. So we'll just write it out here. And then I'll just put these two terms together because they're exactly the same on the insides. Okay, minus 1 times plus 2, we'll put 8 plus 1. And that right there, to me, looks exactly the same as what we were trying to prove. And that is how I use proof by induction to solve this Fibonacci number sequence.